for those of you who are the three new ones, so you got to know what I'm doing here. Okay, I've got the idea is there's a universe to talk about, a lot of stuff. It's really interesting, and generally in the class, I don't get very far down the rabbit hole of the universe because I get sidetracked into really interesting things about the universe. And in the process, I tend to have eliminated talking about the universe. For example, looking for my, this is the universe, okay? This is the universe, all right? And in this universe here, the whole universe, by the way. And in this universe here, I have talked about, well, I've skipped the Earth entirely, okay? I spent a lot of time on the moon. I spent probably a year doing these planets because there are an awful lot of pretty pictures and things to be said. So I did that. And then I started, I somehow or other got confused and spent a lot of time talking about rockets and the space program. And then by the time I regained consciousness, I was all the way out here at the end of the universe, where we have been for a while. We kind of skipped the middle of the universe, like from essentially from the end of the solar system to the end of the universe is sort of the things we've skipped in the last year or two. So there is some hope on my part that we will get from here to here at some point. But there are things that are happening here at Earth and in our solar system that always get in the way of me talking about what I came to talk about in the first place. Of course, what I came to talk about in the first place today is the fact that people are having trouble with the end of the universe. There's a little bit of controversy. People are saying, well, wait a second, what's going on here? We've measured some numbers. They don't seem to be coming out right. People are pointing fingers. You're wrong. Maybe there's something else going on. It's a big deal, and I've been talking about that for about 5 weeks, and somehow or other never got to the point, which is the point in this room. Is as long as I'm just telling you things that will amuse you, you should be happy to be here in the first place. So as long as I can somehow or other relate it to the topic in some way, to connect to the strings of what it is that I'm talking about in some related way, rather than a stand-up comedian doing, oh, and that reminds me of, and then start an entirely other topic. I'm hopefully on topic, and if I can string it together to make sense some way, and make sense, that's good. So, given that, the thing that always gets in the way from week to week is the fact that something happened this week, and it's newsworthy, and we need to talk about it, and we need to stop talking about whatever it is that I promised you I was going to talk about next week, but I failed to. So I promised to talk about next week the Hubble controversy. Okay, I even have videos on YouTube because this, for those new people, I'm on YouTube. This class is being photographed, and the class, me doing this, saying this, will be on YouTube within a week or so, and you'll be able to see it, and you don't have to even come to class. So, but that's not the point, because of the people in this class, nobody in this class has ever seen the YouTube videos except for there's Kurt over there and Elaine. But most people I just put it up on YouTube. That's it. You can come and skip the class, go watch YouTube. But so I was supposed to be talking about the Hubble controversy, but this week, thanks to the powers that be, and in this class I'm not clear on what the powers that be are, because it depends upon whether you're God-fearing or not. The universe has given us a gift from the stars, and that gift is we are being visited by a extrasolar object that has never been in our solar system before, and will never, and is not planning to stay, and is planning to leave our solar system forever. So it was never here, and it will never be here. But for a short time, it is here. It is visiting. We have an interstellar visitor who has and somebody discovered him. And this one is an interstellar comet. We've had one before. And the one that came before, was shrouded in bullshit mystery, in which the New York Times and other media that can sell more newspapers depending upon how high they raise the hype, was capable, raise the level of hype to the question of, is this visitor from interstellar space a alien spaceship? And these questions were really raised, and the answers were given. And the answer is, finally, after many months of conversation, no. What are you thinking? So no.
Too bad.
Really too bad. And there was some real evidence. This thing wasn't behaving properly.
Yeah.
Right. When things behave properly, okay, they do this. See, here's the sun, okay, and what you want is, here's the sun, and what you want is the thing, if it's coming in from outer space and the interstellar medium, it's supposed to come in, do a hyperbola, and go out again, and that's it. And it's a hyperbola. It's what you learned in school when you weren't paying attention. Hyperbola, okay?
Very good.
And it's a very well-defined object in terms of orbital trajectories. Hyperbola. Well, the thing, and in space, you're only allowed three things. You're allowed circles, which never happens. You're allowed parabolas, which never happen. I said four things. You're allowed ellipses, which happens all the time, and you're allowed hyperbolas. You get to have four things and no more. This thing, which was coming from the outer solar system, decided to be a fifth thing. And because it was behaving badly, as far as they were concerned, and therefore under the control of an alien intelligence, they labeled it possibly an alien spaceship. Until they got enough information to discover that maybe it was behaving okay, no reason to assign it an alien spaceship status, and now, so that's done with that one. But this time we've got a new one, no aliens involved, but it's very cool, because this one is the thing about this one is, okay, so so this is the solar system, okay, and we have Neptune and Uranus and so on, Saturn and Jupiter. They're all those four rings that you see there are four of the outer planets. But I'm going to zoom in a little bit more. Well, before I zoom in, I want to just want to spin the solar system around. And you see the solar system lies in a plane. All the major planets, and even the rocky planets, they lie in a plane, just like that. So it's nice. I mean, when you invent a solar system, what you do is, if you're the power that be, the laws of nature, for example, then what you want to do is you want to make a nice flat plane of a solar system, and that's what this is, our solar system. But there is an object that's coming in from this direction here and scooting around the sun here and scooting out there, and you can see the direction from which it's coming is nowhere near in the plane of the solar system. So first of all, that's a clue. And the second clue, the big clue, is the orbit is a hyperbola. Hyperbola means starts at infinity, ends in infinity, with a short visit to the focus of where it's coming to. So this thing, we actually, it was observed by an amateur astronomer who gets his name on it, which is, I mean, amazing. It's amazing. Amateur astronomers are the ones that get to find and label, name the comets. There are all sorts of things to be discovered in the universe, but these amateur astronomers spending their nights looking through telescopes, which I have to tell you is a most annoying thing to do, to be outside in the dark and night, all night long, staring through some sort of telescope in the fond hope of who knows what. But every now and then, some of them find something amazing. And this guy, Borisov, I think his name was, found the second interstellar traveler of all time. I mean, that's better than any comet. There's literally millions of comets, but there's only 2 interstellar travelers, and only one has somebody's name on it. So, as far as I'm concerned, this is a good deal. And this path, by the way, tends to line up not with the solar system, but you know there's a Milky Way out there? What's coming from out there in the Milky Way? So the Milky Way crosses the Earth's sky, not at this. If it was behaving nicely, the Milky Way would do this and be lying right at the horizon of where the Earth sits. But it doesn't do that. It's at an angle, and that's coming from there. So it's literally coming from our galaxy. In case you didn't notice, it's coming from our galaxy. So let's see what it looks like. Now I'm zooming in, and now there he is. It's right over there. Borisov. Borisov is right there. Right there. There's Borisov. And now, but I have Borisov paused. Now I'm going to start Borisov up, and what you're seeing here is once a day you'll see a new picture of it, which comes once every day. So so there's Borisov. 1 day, 2 day, 3 day, 4 day. Every day, it's days after days. You see, it came. Let me reverse it and go backwards. What it's doing is it comes very close to the planet Mars, into the orbit, not much closer. Let me start it again and go the other way. When it comes as close as it can, I'll stop it. Now let's see where it is. So it's around Mars. It's as close to the sun as it gets, is really around Mars. But but the thing is, it's going to be around for a while. And while we can't actually get there to visit it, although in fact we could, if we spent all the money that we had devoted to all the insane other programs that we spend our money on, we could build a spaceship that could literally land on that thing. And we could visit it. But there isn't much of a point in doing it. Nevertheless, we have the technology to do that. So that if it really was an alien spaceship like the first one almost was, we could go visit it. Well, but we're not going to do that. However, we did visit another comet recently, and we spent 2 years visiting it. We went to it, we flew around it, we landed on it, we had a couple of accidents on it, not big ones. You know, the thing that landed on it got lost. It really had a bad time. We couldn't find it for half a year. Finally, we did find it. But basically, we visited a comet that is about the same size as this comet. And I have a movie that has been made of this visitation that is designed to look, it's real, everything you're going to see is going to be really photographed by a robotic spaceship that went to this comet and took pictures and orbited and everything else. The only difference is it's been tweaked a little bit to make it a little bit more mysterious than it has to be. But everything you will see will be real and not some Hollywood Studios version of it. So this is 3 minutes, 3.5 minutes, and I consider this to be about as good a trip into outer space as you could possibly ever have. This is absolutely real. This is a comet.
This is an accurate picture of the comet.
These are all honest, no Hollywood at all.
No colorizing, nothing.
No colorizing, nothing. The music is not real.
It's real, it's just not there.
Just in the atmosphere.
So these are taken up high. Now that's the lander. Okay? And when the lander lands, because it gets really close, and now you know comets have a tail. This stuff that you see, this snow, is literally boiling off the surface of the comet. And when it gets up high, it produces the tail of the comet. But the earlier pictures did not show it from close up. This is close up. This is the thing that landed on the surface, and what it looks like sitting on the surface. There's snow. And this is what it looks like as we leave the comet. It's about 2 miles in diameter. It's about the size of downtown Manhattan. You can see the cometary gases coming off. As it got closer to the sun, the comet got hot and the gases started boiling off.
And commentary? Is there a word commentary?
The comet will continue. 67P will continue on its journey around the sun. It's been wandering around the sun for billions of years. The name of the spacecraft is called Rosetta. It ended its mission by crash landing on the comet. The mission was a big success. It was the first space probe which orbited a comet.
Wow. That is a wow.
How about that?
That is a wow.
Amazing.
And then,
The name of the
Oh my
the name of the spacecraft was also great.
Yeah, the name of the spacecraft. Yes.
Question, was the visuals observed by camera, or did they use some model to infer what it might look like?
That's not a model. Those are actual pictures
Observed by the camera?
by the camera. This is not. They have a model of it, and so there is a way, if not now, but soon, for you to fly over it and investigate it. Oops. There's a way for you to fly over it. There will be a way to fly over it and see it. Because they have the data, they have 400,000 pictures. Okay, every one of those pictures can be, they know where every data point is in 3D. So all they need to do, I'm sure they're doing it, I'm sure they absolutely are doing it. They are looking at every data point, and they're trying to figure out what we just saw was like fun and games for us. But for them, they're trying to figure out, did you notice that the comet was two-lobed? Had one lobe and two lobe? One of the first and obvious, most biggest question for them was, did the comet form as a whole and then lose the part around its neck, or did it come together like this, slowly, and become one out of two things that joined?
Like barbells.
Right, but don't speak out loud. Like,
Out loud.
yes. Raise your hand. Even if you want to say like barbells, okay? Please. Like barbells. The comet, in fact, as far as I know, as far as I remember, was it was decided that in fact it came together as two comets. And we have another example of a comet that came together as two comets, Ultima Thule, which we visited at the edge of the solar system. We have been out in the solar system, not very far. We have been out. Let's see, where's our? Oh, where's the Earth in this? The Earth.
All the way left.
All the way over the left.
That's what you said.
Yeah. Oh, that's right. Hold on. Yeah, there's us. All right, so we have been, so there, okay, right there. We have been as far as there. We've visited Pluto out here, and we visited Ultima Thule. Mm-hmm. And Ultima Thule looks like a two-lobed thing. It seems as if things in the comets, asteroids, are often double, and sometimes they actually come together and stay together. The question is, if they're spinning too fast, they'd separate. But if they're not spinning too fast, their gravity can keep it together.